should be good and all set up now. So we kind of left off, we got our window, or sorry, our camera set up, so no, I didn't want to upgrade Hunter. Now we got our camera working, we got our delta time working and all that. So now we should be able to move on to looking around. Only using the keyboard keys to move around isn't that interesting, especially since we can't turn around, making the movement rather restricted. That's where the mouse comes in. So to look around the scene, we have to change the camera front vector based on the input of the mouse. Gotcha. However, changing the direction vector based on the mouse rotation is a little complicated or requires some trigonometry. So I already did all that. So if we take this knowledge in a given yaw value, we can create a camera direction vector. Gotcha. Okay, so I remember I left off here kind of confused because it didn't really tell us where we define. So I'm guessing, so we got our cosine of sine, gotcha. Okay. Okay, the yaw and pitch values are obtained from the mouse. Okay, so first, we'll tell GLFW that it should hide the cursor and capture it. So after this call, whenever we move the mouse, it won't be visible and it should not leave the window. Okay, so that might need to go into the... Okay. To create the pitch and yaw values, we need to tell GLFW to listen to the mouse movement events. We do this by creating a callback function with the following prototype. Gotcha, so... I don't like this music, it's kind of mid. There we go. Okay, so I'll just do this after. Here, X position and Y position represent the current mouse positions. As soon as we register the callback function with glfw each time the mouse moves, the mouse callback function is called. GLFW set cursor callback. Okay. When handling mouse input for a fly-style camera, there are several steps. We need to calculate the offset, add the offset, add some constraints to the minimum maximum pitch values, and calculate the direction vector. The first step is to calculate the offset of the mouse since the last frame. We first have to store the last mouse positions in the application, which we initialize to be the center of the screen. Okay, so right here we could do something like we want to store the last mouse positions. So we want to do float last x. Okay. Then the mouse's callback function, in the mouse's callback function, we create the offset between the movement between the last and the current frame. So now x position minus last x. Last x. And then we need to reassign them, so we do and then const, we need to set our sensitivity for our mouse. sensitivity, and then y offset. Note that we multiply the offset values by a sensitivity value. If we omit the multiplication, the mouse movement will be way too strong. Fiddle around the sensitivity value to your liking. Next, we add the offset values to the globally declared pitch and yaw values. Okay. Hey, how's it going? I'm gonna say HG because that works better for me. HG. I'm here for a little. Awesome. Happy to have you here. How's it going? Newt, I don't know if I've seen you here before. It's going good. I'm just doing some review kind of. I'm working on the camera section of Learn OpenGL. So yeah, we're trying to get. Let's see if I'll show you what I got built so far, but basically we got our 3D scene rendered here essentially, and we're trying to get it so we can use our mouse movement to look around instead of just having a static, like, left, right, front, back. So yeah, that's our next step, is to make it so we can like fly around and look around. So now we need to add, I'm guessing, float, yawn, pitch. I don't really understand most of the code is doing, but it's still fun to watch. Hey, I appreciate you. I mean, it's good to have you here. If you have any questions about what it's doing, let me know. I can do my best to explain. So one of the things and the purposes of my channel right now is obviously to help me learn stuff from scratch a little bit more. I've taken the learning approach of writing stuff down by hand and using this YouTube channel to talk out loud and teach others. And it's been really good for me to learn stuff from scratch for sure. But yeah, if you have questions, let me know. Right now we're basically using a bunch of math to calculate our mouse movement between frames. So whenever we move our mouse up or down or left or right or whatever, we have our pitch and our yaw values kind of like a plane. So we have like our pitch that goes up and down, and then our yaw that goes like left and right, and then roll is what goes around that as well. And then basically what that does is if we calculate the vectors, like the frames between each time the vector moves, we can figure that part out. Yeah, anyways, it's hard to explain. Same for me, not quite there yet, but it's always nice to watch. Hey, nice, that's good to hear. I mean, I am happy to just have people in here. If you guys, I don't know if you guys have subbed already, but feel free to, but also join the Discord. We have a fun little community growing, and it's always fun to like talk to people and get people's opinions on the streams. I'm working on some videos. I have a video that I have in the making. I'm taking a little bit longer on it because editing takes so much longer than I thought it does. It's like that's why I prefer streaming, is because I just get to be kind of open and honest in the moment most of the time. So like, let's see, we'll do float, pitch, float, yaw. It's funny because I'm not even doing C++ for work, at least not yet. And so it's been fun to learn this on the side for sure. In the third step, we'd like to add some constraints to the camera so users won't be able to make weird camera movements. Also uses a look at flip once the direction vector is parallel to the world up direction. The pitch needs to be constrained in such a way that users won't be able to look higher than 89 degrees, and also not below negative 89. This ensures that the user will be able to look up in the sky or below his feet, but not further. Oh, okay, gotcha. So what is up with this music? There we go. The fourth and last step is to calculate the actual direction vector using the formula from the previous section. Okay. Are C++ jobs hard to find for work? I barely see any whenever I look. Yeah, it depends. I mean, so I know I think that like with lower level jobs such as like, I'm thinking the job that kind of comes to my mind is like NVIDIA or like AI companies nowadays that also have GPU related companies have a lot of C++ devs, but also quant devs. So I think that there are a lot of jobs out there, but there's not as many entry level jobs. There's definitely a lot more senior jobs, especially in those fields. But I think that there are jobs. I actually think that C++ is a pretty in-demand language still. It's just not as in the spotlight as like JavaScript or Python. I think so. Even though I don't really know anything about like that, since I just try and learn coding a bit occasionally, but it's probably rare to find a C++ job because of AI and things. Yeah, I've only heard mostly quant dev, embedded systems, and some hardware companies. Yeah, that's kind of like the basics of it. I mean, to be honest, that's what C++ is best for, is like low-level power, and you're not going to use C++ really to run a web server or, like that's what JavaScript has been made for, or TypeScript. But if you really want to make games especially, I think it's really good to know. I also think that C++ is a really good foundation language to like jump to other languages from. In some ways, I would say C is the best foundation language, but yeah, I would say if you're good at C++, you won't have as much of a hard time learning Java, for example, or C#. Radians. Dude, Radians are great because, this GLM Radians actually converts it to degrees. which I didn't know what radians were until like last year, which is so funny, but I used them a lot in an orbital simulator. And they're a lot better for math and when you're trying to calculate directions. Okay. The computer direction vector will then take all the rotations calculated from the mouse's movement. Since the camera front vector is already included in GLM's lookat function, we're set to go. If you now run the code, you'll notice the camera makes a large sudden jump whenever the first window receives focus to your mouse cursor. Mouse callback. Oh, gotcha. This needs to be declared outside, or I'll just declare this before main. Oh yeah, look at this, guys. We can now look around with our mouse. That's actually so cool. I love this. So now this is a big first step from where we were at, because now, like, let's say that we start making a game. We'll be able to look around. I mean, that's a big deal. That's awesome. I know decently about them from Python. Import math.radians, put degrees in here, then do it 2 more times for the other axis things. Yeah, I'm putting most of my marbles into systems programming, but still quite worried once I finish college for the systems roles. Yeah, so I guess if you want to hear my piece on this, I just got an internship offer today, which is great, for a project management role, which I'm actually doing a lot of cloud computing stuff with, which I'm decent with cloud computing. Obviously, I prefer lower level systems programming, and this is why I do this stuff on for fun on the side. But I would say project management is a really good route to go for safety, at least to start. Like, if you just need to find a job out the get-go as a software developer and you need experience in something, like project management you can't go wrong with, because you still can do Python scripting. And I had another project management internship and I did a bunch of Python scripts, and that still taught me so much. Just depends on where you work, obviously, but yeah. But yeah, look we got the camera working. This is great. Hey, I appreciate it. I definitely am relieved to have something lined up. It'll be good because I think the more experience you have that's relevant to what you're doing, it's easier to get your foot in the door into other places. That's the biggest thing, honestly, is like jobs nowadays. You just need to have good networking. Networking is everything. What OS is this? I'm curious. This is Mac OS. So I'm on my Mac right now. For my desktop actually, I use Linux, but I don't know, I've just been doing all my work on my Mac, and it's really nice, honestly. I love my Mac. I would say that most people should use Linux, but I like Mac for just doing my work, mainly. Everything else I use my Linux system for gaming and all that. Also, feel free to join the Discord, guys. Let me put that in the description. Or I'll put it, it's in the description, but I'm going to put it in the chat. And then pin it. There we go. Okay, it should be pinned now, so you guys can see that. And join if you feel free, and also sub, obviously. Hey, how's it going, KL? I use Arch. Dude, I use Arch too, except it's Cashy OS. It's just a little more. I mean, same distro, just different libraries. I like Cashy just because it's a little more put together out of the get-go, but I prefer Windows because a lot of apps and installments support it, but Linux doesn't. If some of those supported Linux, I would definitely switch. I think that's a fair point to take. I would say Windows makes sense to prefer for most use cases, but I would say that it's not a better OS. And when it comes to, I don't know, like there's been such a boom in AI, like bloat, that I feel like Windows has definitely been like, I haven't touched it in months. Like I actually have my PC dual booting Windows, and I'm like, the only reason I would ever see myself using it really is for Visual Studio, which is Microsoft's C++ IDE. But honestly, I do fine with VS Code for now, and I probably will switch to Neovim here soon. Okay, blah blah blah. We can circumvent this issue by issuing a global bool variable to check if this is the first time we receive mouse input. If this is the first time, we update the initial position to the new X position and Y position. Okay. So now we got our camera working, which is awesome. But yeah, preference is huge. I prefer Mac OS or I prefer Linux over Windows, but like at the end of the day, whatever gets the work done is what matters. It's really, I'm not going to tell people that they can't be a good developer if they. It seems like you're almost done. Also, I usually try and delete that part of the code that I just learned and then quickly put it back without copying and paste to make sure I learned and remembered it. Yeah, that's fair. I probably should do that, actually. I usually do that. I'm just like, if you can't tell, I am out of it. That's not what I meant. Okay, you got it. Yeah, I think it's good to rewrite code. Actually, that's what I typically do off stream, is I learn this stuff on stream and then I review it when I'm chilling out. And then I also, obviously, I write most of my stuff down. I'm not really writing this stuff down with the mouse just because I feel like it's something you set up once, at least to start. And I can come back to this chapter. Okay, there we go. Now you can see we can move freely around the 3D scene. So now we got, this is really cool actually. Yeah. If you guys are new here, feel free to sub and like, and join the Discord like I said. I'd love to talk to you guys, have you there. Okay, to add a little extra to the camera system, we'll also implement a zooming interface. In the previous chapter, we said the field of view, or FOV, largely defines how much we see of the scene. When the field becomes smaller, the scene's projected space gets smaller. The smaller space is projected over the same normalized coordinates, giving the illusion of zooming in. To zoom in, we're going to use the mouse's scroll wheel. Similar to the mouse's movement and keyboard input, we'll have a callback function for mouse scrolling. Okay. I can't wait till we can start putting this stuff in like classes, because yeah, it's getting really bloated in one file. One flaw I think that I found was when you like full screen, the blocks start to stretch outward. Not trying to be rude. Oh no, you're good, man. That's actually just, I'm just following the tutorial at the moment. So it's kind of set up right now to where it'll be, the aspect ratio is set up to only work within this confined window size. And when I enlarge my screen or whatever, it's going to be more stretched. So yeah, it's supposed to look like this right now. This is just like the very beginning. That's my biggest problem right now, is that I can write code from scratch, but I need Claude to help me with ideas. Oh, okay. Yeah, I think I've struggled with that. I mean, I struggled with that about 6 months ago. Like I said, that I've been doing this. I've been streaming on YouTube for about 4.5 months now, and it really took me a while to get the hang of learning from scratch again. It can be difficult, and I understand that. Like, for me, my biggest suggestion, if you're learning, is get a pen and paper, write down like what it is you are building. So like, let's say you start off super simple with like a calculator app. The first thing you want to do is be able to add 2 numbers and have that display to the console. So you start there. You say, okay, what do I need to make a function to add 2 numbers? You basically just define 2 variables, numbers that you'd add. Put those into your function, return whatever the result is. And then next, what you want to say, okay, now I want to be able to call that through main from a class. So then you would want to make a class that can handle an addition or subtraction. And you kind of just go break it down into smaller things. That's the thing with coding, is like, you can't jump into the big picture. You have to start really small from the foundation of like what you have to do. You have to be super simple. So yeah, just my biggest suggestion is, bye, gotta go. It was fun being at the stream. Hey, thank you, HG. I hope to see you in the next stream, or whenever you're around next. Feel free to join the Discord and subscribe if you want to be here. Thank you for engaging and talking. It was fun. Also, Kyle said, I'm not good at ideas. Or I'm good at ideas, but I'm not good at code. I mean, I think coding is one of those things where you just gotta, it's like exercising a muscle. I'm already subbed anyways, actually, by this time. Sounds good. Thank you. I'll talk to you later. Okay, so now we need to say this is going to cast this to y offset if FOV, not cast, it's just going to set it to a float. And then we say FOV equals 1.0. Okay. When scrolling, the y offset value tells us the amount scrolled vertically. Still learning C++ fundamentals. Using Claude takes too much time. Here's my suggestion. If you're trying to learn fast, AI is going to be good if you have a specific plan in mind. Phil's limits. I'd say if you're using Claude specifically, use just like the Sonnet model, and give it like a very detailed prompt so you can get the most out of it. Prompt injection is big, with like having detail saves you tokens for sure. But honestly, like, try and learn in a way where you can speak out loud. You'll learn way better. Opus uses it fast, but Sonnet lasts a while. Yeah, honestly, I don't use Opus very much. I think Sonnet is great for most stuff, in my opinion. We know how to upload the perspective projection matrix to the GPU each frame, but this time with the FOV variable as its field of view. Oh, gotcha. And lastly, don't forget to register the scroll callback function. Alright, let's see if zooming works. Let's see. Oh, gotcha. My if statement has a... Oh gosh, what did I do? Let's see. When the project gets complex, it fills up in one message because it also looks at past messages too. I think I will use it only for teaching. If you're learning C++, my biggest piece of advice is only use AI as a last resort. I think you're gonna learn a lot more by just pushing yourself and learning from scratch. I think you'll learn more as you just keep writing stuff by hand, because AI is just gonna, I don't know, I feel like it's kind of, AI is very easily, it's easy to use it to just get to the solution, especially when you get tired. I've been there, and that's why I'm saying that. Let's see what I did wrong here. Okay, oh, I need a set. Alright, so we got our pitch. Oh, we need to set pitch and yaw to different. So pitch is 0, yaw is -90. Last x equals 800 divided by 2.0. And this is going to be FOV is 45. Let's see. It gives me exercises, I do it and send it to check. Yeah, I mean, that works. I would say that's fair. I was just gonna say be careful because it's really easy to get, you know, cut. It gets into a weird. Oh, look at that. And we got our zoom. That's so awesome. Yeah, it gets into a weird mode of like, if you're not careful, it'll take away your learning, and I think it takes away your failure. Like, failure is what really gets you to learn. Look at this. This is so cool. Look how it like goes out of frame. That's so cool. Okay, so camera class. In the upcoming chapters, we'll always use a camera to easily look around the scenes to see the results from all angles. However, since the camera code can take up a significant amount of space on each chapter, we'll abstract it and its details a little and create our own camera object that allows us to do most of the work for us with some neat little extras. Unlike the shader chapter, we won't walk you through how creating the camera class, but provide you with the full commented source code if you want to know the inner workings. Like the shader object, we want to define the camera class entirely in a single header file. You can find the camera class here. You should be able to understand the code after this chapter. It is advised to at least check the class out once as an example, but you should be able to create your own camera system here. Yeah, that makes sense. Let's go to our include. Alright, so let's see. Do you have an end goal with learning OpenGL? Yeah, I would love to learn build my own game engine. So I kind of want to use this to do a lot of physics simulators and stuff like that and learn the math behind it so that I have pretty good in-depth knowledge of C++, but learn OpenGL is just a really good tool, I think. Okay. Now if we go up here, we can include our camera. I'm almost done for the night. And now nice, I'll definitely follow your journey. Hey, I appreciate it. Thank you for being here. It's been really good because I've been able to talk to a lot of people about this, and like, I honestly think the biggest thing is I do want to build a game engine, but I want to just start by building a bunch of small programs and say that I built all these from scratch. Honestly, it's really a cool thing to be able to say that. Alright, let's see. So then this takes, instead of our view, let's go. Alright. Freaking chair is so squeaky. Okay. So we got our projection, which our projection takes, instead of an FOV, it takes our camera.zoom. Okay, so these all go at the top. I thought these had to go in the render loop. Syntax error, I've had a lot in the past. Yeah, I'm just kind of cleaning up the camera class, using the camera class it gave me. Shouldn't take me long. Now, okay. Well, this is not good. Now I'm stuck. There we go. I just need the process input. Now that I have a lot of logic, errors. Yeah, honestly, syntax errors are not that hard in comparison to logic errors for sure. Oh, I forgot to put this at the top. What compiler do I use? I think I'm using G++. There we go. Okay, everything's working now with the camera class, which is great. Got camera working. Which I do need to increase my camera speed, so let's go to... Actually, not our camera speed, we need to go to our process input, and maybe it is our camera speed. Oh, yeah, we need to change this to like 10. just want to see where our movement speed is, so. Pretty sure this is our movement speed. Yeah, I'm using G++. Okay. I think that's a good place to stop. I'm gonna stop there for tonight. Tomorrow I'm gonna do more review and write. I'm gonna go probably through and write some stuff down on my own time from the chapter, just because I didn't write much down today. And then we're gonna do the exercises tomorrow. Make sure we completely understand the camera and how it works before we do the final chapter of the getting started, which is, I think it's just a review. Let's look at it. We can take a quick peek at it. Yeah, basically, now we can create a window, do all that stuff. Yeah. Now and then I'll probably use this to get this all working good. I'm gonna probably use DRM GUI for like utility windows and stuff, but yeah, did good. We got quite far and we're making good progress. So have a good one, guys. Feel free to join the Discord like I said, and subscribe if you're new here. I appreciate you all being here, and keep learning, and I will see you in the next stream. Thank you.